we are going to solve some exercises. In solving the exercises, we are going to apply the derivative of the tangent function as well as the chain rule, product rule, power rule, and difference rule for derivatives. The derivative of tangent is secant squared. It is written as the derivative of tangent x with respect to x is equal to secant squared x. Let us find the derivatives of the following. Number 1, y is equal to tangent of 8x. Here we are going to apply the derivative of the tangent function, the chain rule, and the power rule. We are going to find the derivative of the outside function here, and then the derivative of the inner function. The inner function is 8x. So the derivative of y is equal to secant squared of 8x times the derivative of 8x with respect to x. This is now equal to secant squared of 8x times 8. 8 is the derivative of 8x with respect to x using the power rule. Then write 8 before secant squared of 8x. So this is now equal to 8 secant squared of 8x. The answer is 8 secant squared of 8x. Number 2, y is equal to tangent of 6x squared minus 2. We are going to apply the derivative of tangent, the chain rule, the power rule, and the difference rule for derivatives. So we are going to find the derivative of the outside function here and the derivative of the inside function. The inside function is 6x squared minus 2. So this is now equal to the derivative of y is equal to secant squared of 6x squared minus 2 times the derivative of 6x squared minus 2 with respect to x. This is now equal to secant squared of 6x squared minus 2. The derivative of 6x squared using the power rule is 2 times 6, 12, and then subtract 1 from 2. So this becomes 12x. Then minus the derivative of 2, the derivative of a constant term is 0. So this is 12x minus 0 is 12x. So times 12x. And then write 12x before secant squared of 6x squared minus 2. So this is now equal to 12x secant squared of 6x squared minus 2. The answer is 12x secant squared of 6x squared minus 2. Number 3, y is equal to 5x raised to the exponent of 4 tangent x. Applying the product rule for derivatives, we have the derivative of y is equal to 5x raised to the exponent of 4 times the derivative of tangent x with respect to x plus tangent x times the derivative of 5x raised to the exponent of 4 with respect to x. This is now equal to 5x raised to the exponent of 4 and then secant squared x plus tangent x times 20x cubed. The derivative of 5x raised to the exponent of 4 using the power rule is 4 times 5 is 20, and then subtract 1 from 4, x cubed. So 20 x cubed. This is now equal to 5x raised to the exponent of 4 secant squared x plus, write 20 x cubed before tangent x. So we have plus 20 x cubed tangent x. So the answer is 5x raised to the exponent of 4 secant squared x plus 20x cubed tangent x.